We've talked about simplifying square root radicals in the numerator and the denominator. Today we're going to start talking about cube root radicals. The first thing we have to remember is that if we see a cube root radical, for example, cube root of 54x to the 7th, another way of reading that is 54x to the 7th all to the 1/3 power. This is going to be important for us later. So just like we did before with the square root radicals, the first thing we want to do is to break it apart using the product property. So because they're being multiplied on the inside, it's totally okay to split them apart so that they're like this, multiplied separately. Then let's take a look at 54. Just like we did with the square root radicals, I'm going to make a factor chart to see if I can break this down into any numbers that are easier to work with. Remembering that cube root means what number times itself 3 times equals this number. The first thing I'm going to do is say, well, I can divide this by 2. Once I do that, I get 27. If I were to keep going with this and divide by 3 and then divide by 3, when I finish simplifying, what I see is that I have the same number 3 times, because 27, when you take the cube root of 27, you're asking yourself what number times itself 3 times equals 27? The answer is 3. Let's see how this translates into our assignment. We're going to break this apart into multiple pieces. We have the cube root of 2, which is just hanging out over here, times the cube root of 27. So I've just broken apart the cube root of 54 into 2 pieces, cube root of 3 and cube root of 27. Then over here, we still haven't simplified this one. We're just going to leave it for now. Once we do this, we say, I know that this, the cube root of 27, is 3, which automatically means it comes over here on the outside of the radical. I'm going to write 3 times the cube root of 2 times the cube root of x to the 7th. So I've simplified this and I move it to the outside where it is free of the radical. Now that I've done that, I see that, well, 3 can go into 7. So I'm going to have to simplify this as well. So let's just go ahead and write this part which is already completely simplified, and then we'll tackle this part here. So just rewriting 3 times the cube root of 2 times the cube root of 3 times x to the 7th. But let's figure out how to simplify this part. If I remember that I can rewrite this as x to the 7th to the 1/3, I probably want to split it into 2 pieces. One that can be divided by 3, and one that has whatever's left over. If I divide 7 by 3, I get 2 with a remainder of 1. So what that tells us is because we have 2, it can be divided evenly by 2 with a remainder of 1. What that then tells us is that if we take 2 times 3, we get 6. So we're going to rewrite that as the cube root of x to the 6th times the cube root of the remainder, or x to the 1. And when I add up 6 plus 1, I get 7. So I know I've split it correctly. Now that we've done that part, just like we did with the square root radicals, we have to simplify the cube root. Now remember, with the square root radical, we divided the exponent by 2. With the cube root radical, we divide the exponent by 3. So 6 divided by 3 is 2. So we'll actually get, and remember that this frees it from the radical, we'll get x squared. And because it's been freed from the radical, we move it to the outside, just like we did with the 3 over here. So when we move it outside, we're going to get 3 times x squared times this left over here, the cube root of 2, times this left over here, which is the cubed root of x to the 1, because you cannot divide 1 by 3 evenly. Once we do that, we can simplify the whole answer using the product rule of radicals. We're just going to write 3 times x squared as 3x squared. And then this here, because it's all cube rooted, we can write the multiplication problem on the inside. So we just put 2x and we combine it inside the cube root radical. So now we have fully simplified. There's also nothing in the denominator, so we don't have to worry about that. at all. Let's do another example. Here we have the cube root of 16x to the 12th, y to the 5th. Right away, I'm going to go ahead and break that into 3 separate pieces, since we have 3 different things being multiplied on the inside here. I've broken it apart into 3 separate pieces. As always, the first part I'm going to tackle is this number part here. What this is asking me is, what number times itself 3 times equals 16? We know that none of those fits the we know that there actually isn't a nice whole number that multiplied by itself equals 16, so let's just look and see if there's any perfect cube roots on the inside of that by doing a factor chart. If I start factoring out 16, taking out prime numbers, so now I'm going to look for groups of 3. Looking at this, I can see, oh, there's a number multiplying by itself 3 times, and I know that 2 times 2 times 2 equals 8. So this is the perfect cube that I'm going to take out of this expression here. So that's going to look like the cube root of 8 times the cube root of 2, this leftover number here that didn't get factored out. Okay, and then we just rewrite this other stuff because we're not doing anything with it yet. Awesome, so we know that the cube root of 8 is 2 because 2 times 2 times 2 equals 8. So this frees itself from the radical and just becomes 2. Or the cube root of 2 we can't do anything with, so we just leave it over here. With the cube root of x to the 12th, we look at the exponent here and see, well, 12 is already divisible by 3. So all we have to do is say 12 divided by 3 is 4, and we bop that to the outside over here, just like we did with this, and we write x to the 4th. And there's nothing left over. Over here we have a little bit more of a tricky situation. I'm going to have to split this into a number that can be divided by 3 and a number that's left over. So I'm going to go back and do what I did in the last problem. I'm going to say, okay, how many times does 3 go nicely into 5? Well, I know that it goes in once, and my remainder is 2. What that tells me is I'm going to have an expression of the cube root of y to the 3 times the cube root of y squared. So this has been broken into 2 parts. After that, I can simplify even further because I know that if I divide 3 by 3, I get just 1. So y to the 1, again, will get moved to the outside, and we then have 2x to the 4th y to the 1 times this left over here that we can't do anything with, times this left over here that we also can't do anything with. So we use the product rule to just combine this and this into one cube root expression. And now it is fully simplified.